Hello, the purpose of today's little video is to go do a review of solving simple equations algebraically. We are going to talk about some of these equations that we're going to solve by algebra. We have used other methods, but we're going to specifically look at algebra this time. So before we do that, let's talk a little bit about what an equation is in this case and what is that we're trying to accomplish. So take a look at these equations. They all look different in some ways, but they all have a few things in common. See if you can identify one or two or three things that all of these have in common. Take a moment to look at them. Well, I hope that you are able to see that all our equations have an equal sign, that they all have a right side, meaning to the right of the equal sign as we're looking at them, uh, and a left side. So they both have a left and a right side, and the two sides are equal. They also all have, in this case, one variable. In most cases, it's x, but this one, for example, has an a squared. But they are all having a variable which is what we're trying to find the value of. In other words, our goal when we are solving equations is to identify or to determine values of our variable that make our equation true, a value that makes the left side equal to the right side. And we're going to talk about a variety of methods and some key ideas to solve these equations. The first one that we're going to look at is something that is very friendly, very easy, something that we call solving by inspection or solving by guess and check. Then we're going to talk a little bit about other methods that you probably know, something that we will call the balance method that involves using opposite operations, which means to balance whatever we do to one side with whatever we do the same thing to the other side. And then we are going to talk about multi-step equations and give you an idea that may help you find solutions in a friendly manner. And that is undoing what is happening in reverse order. We're going to talk about that in a bit more detail soon. So here is our first type of equations. These are friendly because we can almost solve it immediately. Take a look at this one, for example. X plus 4 equal 11. Well, what we're really looking for here is a number that when added to 4 produces 11. By now, you probably figured out that the number we're looking for is 7. And that is the solution to our equation. So 7 plus 4 equals 11. We can solve these by inspection. Really, there's no need to do anything more complicated than that because we're able to use our arithmetic and just answer the question, realizing that 7 makes the equation true. What about this one? What this equation is asking us to find is a number that when subtracted by 5 produces 20. So take a moment to think what number minus 5 produces 20. You probably figure out already that the number we're looking for is 25 because 25 minus 5 equals 20. So x equals 25 is the solution to our equation or the value that makes our equation true. Two more to solve by inspection. We also say guess and check because we can put different numbers for the x to see what works. So for example, if we had initially thought that x was 10, if we put 10 minus 5, we realize 10 minus 5 is 5, is not equals to 20. So then we would find or look for another value. So here's the next one. This equation is looking for a number that multiplied by 3 produces 12. So 3 times a number equals 12. Can you figure what number that is? The answer is 4. So 3 times 4 equals 12. X equals 4 is the solution to our equation because it makes the left side and the right side equal. And we didn't really have to do anything except to go and tap into our previous knowledge of multiplication and knowing or remember that 3 times 4 equals 12. One last. So here we're looking for a number that when divided by 4 produces 5. Well, think about what number that could be. And if you said 20, you are correct because 20 is the value of x that makes this equation true. 20 divided by 4 equals 5. Therefore, x equals 20 is our solution. So this is a very friendly method and is a perfectly valid method for you to solve equations. You can solve these equations by inspection or by guess and check. But we cannot always do this. And we're going to talk about that in a moment. But before that, we're going to play a little game that has to do with opposite operations. This is actually a very friendly game. But play along as we show and we advance on the video. So the question here first is which operation is opposite of the one that will appear? Well, if you said addition, you're correct because addition and subtraction are opposite operations. Subtraction undoes what addition do and vice versa, meaning if I'm adding numbers to do the opposite or to undo that, I would use subtraction. So we use these to solve equations and we complement that with a balance method. So let's look at one example here. Let's say we have this equation, and for the moment, let's pretend we're not going to solve it by inspection. So we have an equation that says 35 equals x minus 8. Well, if we realize what is happening to our variable, and this is very important further on, I can see that the number that I'm looking for is subtracted by 8. For me to cancel this subtraction by 8, I would do the opposite, which is the addition. And here comes the balance part. Whatever I do on the right side of the equation, I must do on the left side of the equation so my equation stays balanced. So in this case, what I would do is to add 8 on both sides. Why do I do that? Well, the answer is relatively simple. What I want to do is create a 0 next to the x on the right side in this case, because minus 8 plus 8 produces 0. That means that on my right side, the only variable that is going to be left is x. And if I perform this calculation, 35 plus 8, I realize that that is 43, and that is the solution to our equation. So x equals 43 is the solution to the equation or the number that makes this equation true. And what I did was look at the operation that was happening, and by doing the opposite, I am undoing what is happening, and I must do it on both sides. Let's look at a different example. What is the opposite operation of multiplication? Well, if you said division, of course you're right. Division and multiplication are opposite operations. A division undoes what a multiplication do, and vice versa. So we use that to solve equations like this one. So in this case, I can see that my variable is being multiplied by the number 6. So what I need to do to isolate the x, to find the value for the x, is do the opposite operation of multiplication, which would be division. And in this case, I will do that on both sides. I always do this on both sides. So I'm going to divide 6 by 6 on the left side, and then 42 by 6 on the right side. And that I can see when I divide 6 by 6 produces the number 1, which tells me there is 1x, or the value that I'm looking for. So the value of 1x is the value of 42 divided by 6, which is 7. So 7 is the solution for this equation because 6 times 7 equals 42. Okay, here's another one. See if you can come up with the first operation or the opposite operation. Be careful. This one is a little tricky. Well, this one is tricky because we have this negative in front, and sometimes that makes it like a puzzle. We are not sure if what is happening is a subtraction or a multiplication. Well, if we look at it carefully, we can see that the x really is being multiplied by the number -4. So this is very similar to the one we just did. And what we need to do is basically the same process. Of course, the numbers are different, but if the x is being multiplied by -4, what I need to do is divide both sides of my equation by -4. And this is what I get when I do this division. And by doing that, especially on the left side, what I have is that dividing -4 by -4 produces the number 1. A negative divided by a negative is a positive, and 4 divided by 4 is 1. So I have 1x is 24 divided by -4. And 24 divided by -4 is equals to -6, because a positive divided by a negative produces a negative. So take a moment and reflect a little bit on this second one, because although at first we may think it involves subtraction, it really doesn't. It involves multiplication. Okay, here's the next case of opposite operations. So let's see if you can tell which is the opposite operation for squaring a number. Well, if you thought that the square root is the opposite, of course you're right. Uh, Squaring, meaning taking a number and multiplying it by itself, is the opposite of square root, which means we're finding the number that multiplied by itself produces the original one. So the square root and the operation of squaring are opposite operations. And when do we use these in solving equations? We won't have as many of these, but sometimes we will use these when we solve Pythagorean theorem questions, for example, or equations like this. Take a look at it. X squared equals 25. So we're looking for a number that multiplied by itself gives us 25. Some of you may be able to solve these by inspection, but take a look at what we're trying to do more formally. We are doing the opposite operation. We are doing the square root of x squared, meaning we do the square root on the left side, and of course we do it on the right side. So when I perform the square root of a number squared, I end up with the same number. In other words, I am doing the square root on the left side to cancel the square, and that will produce the variable by itself, which is my goal. The square root of 25, in this case, we're going to think is the number 5. There's another answer for that, but for now, we're just going to stay with a positive square root. So the positive square root of 25 is 5. And we have completed doing operations and balancing equations by reversing what one operation did. Now, the last two examples we're going to look at is equations that have multiple operations in them, or multi-step equations. And here's the key idea. We're going to undo in reverse order what is happening to the variable. So here's the question we ask ourselves. What operations are being done on the x and in what order? So let's look at the first example to make this clear. First, let's identify that our variable is on the left side. Here's our variable, our unknown that we want to determine. Here's the x. So now let's take a moment, see if you can determine what operations are being done on the x and in what order. Take a moment to think about it. Okay, if you said that the first operation is a multiplication by 3, you are correct. 3 multiplies the x, that's the first operation, and the second operation is a subtraction. We're subtracting 11. So we are multiplying by 3 and then subtracting 11. The way we will isolate our variable is by doing the opposite operations in the opposite order. So if the first operation is multiplied by 3 and the second is subtract 11, the first thing we're going to do is to add 11 to both sides, because we're undoing what's happening. So this is our first step, adding 11 on both sides before we do the division or multiplication part. And the reason for this, well, hopefully you can see that now we're going to cancel. We're going to make a zero pair with the -11 and the +11 on the left side. And what that will produce is 3x on the left side, 13 plus 11 is 24 on the right side. Good. Well, this looks a lot like a previous equation we did. And the question here is what operation is happening? We already had determined that the first operation was a multiplication by 3. So now we're going to do the opposite, which is the division by 3. And when we do that, we can see that the x will be isolated, and the answer would be 24 divided by 3, which is 8. That is the value that makes our equation true. The key idea here is that we are realizing what operation happened on the x, in what order, and then we're doing the reverse, the opposite operation in reverse order. We're going to do one last example to hopefully help us further understand this. Okay, so take a look at this one. This one is also a bit tricky. Our variable happens to be on the right side, and that's fine. Sometimes the variable is on the left, sometimes the variable is on the right. That's perfectly good. So our unknown is on this side. Now let's take a look at what operations are happening to it and in what order. Take a moment to think about it. Okay, the first thing we notice is that there's a -2 next to our variable. The operation that is happening here is a multiplication. In other words, x is being multiplied by -2. So there's a multiplication, and then the next operation, although we can't see it explicitly, we are adding this 5. So if I were to look at it differently, I would think, here's my variable is being multiplied by -2, and I started with 5. And that means that I added the 5 to the multiplication of the -2 times my variable. So there's a multiplication first, and we say first because it's closer to the variable, and then an addition. That means we're going to undo the addition first and then the multiplication. That means we are going to subtract and then divide. So here it is. First, we are going to subtract 5 from both sides. These might be a bit hard to see, but the purpose of this step is to make sure that this 5 becomes a 0 on the right side. So if I subtract 5 on this side, I have to subtract it on the other side. And the important result here is that 5 minus 5 on the right side equals 0. And that will leave just the -2x on the right side. 27 minus 5 on the left side is 22. And this looks a lot like an example we did earlier, and we already know that this was a multiplication. So the opposite is going to be a division. So we're going to divide our equation, both sides, by -2, because that's the number that is multiplying the x. And this is a bit tricky, but that's why we're doing this example, to give you an idea of a situation that is a bit unusual. So here we go. We divide both sides by -2. And on the, there's an error here. This x shouldn't be here. Sorry about that. On the left side, we only have the 22 divided by -2. Please forgive this x. I don't know what it's doing here. Mr. Garcia made a little mistake. But on this side, we have -2 divided by -2, which is 1. And at the end, that produces our value here of -11. I hope you are able to see the process. We are undoing what is happening in reverse order. And everything that we do to one side, we do to the other. So this was a quick review of equations. A lot of things you already know, already knew. We're going to solve equations that are a bit more tricky, but that will be for another video. Thanks for watching.